Hey everyone, welcome back to the second devlog that we're doing. I'm Colin Rivers, and it's been about 3 weeks since the last recording, and we've actually covered a lot in game programming right now, it says. So we've covered input such as keys, we've covered sound, we've covered images, and we've also covered threads, which is the looping system that I discussed. So it's going to be a lot for me to implement in this session. I'm not sure if I'll be able to add all of them, but priorities first, I'm going to try to add a rendering loop and threads first. Well, that's the rendering loop. So I'm going to add the rendering loop, and then I'm going to add keyboard input. So if you recall, we wanted the code to say, if the key is down, do this, otherwise do that. That's what we're going to look to do. And for that, we need to run some scripts. And I think what we discovered lambda functions is what we could possibly use for that. But for now, just a small recap of everything we've created so far. I'm just going to run our program. And you can see that everything here has been added. So what we did, we initialized the Java engine. We created one JevaClip, giving it some default properties. And then we attached 3 JevaClips to the screen with different properties and positions, and they're displayed. We had to manually call the render engine, but now that we're getting the loops and the threads in, we won't have to call this anymore, and I can make this private. So what I'm going to do first is try to get a loop running, and internally, each JevaClip would just have an increase in X value as it goes on. And that's just to ensure that everything works correctly. One problem I think still exists with loops is the rendering is not in sync with the computer as yet. But we try. Let's see how far we can get. So to start, I'm gonna try to modify Sir's code again, because I'm always using help from him. And in here, in his game panel, he implements runnable. That's because the game panel already extends JPanel, so you cannot extend thread. So you had to make it implement runnable, which allows him to create a thread variable called game thread, and inside the game thread is equal to new thread, game thread start. So we're gonna do something just like that in our engine. Rather than doing it in the Java screen that contains JFrame and has different game panels and stuff, I'm gonna do it in the initialized JevaR engine. And that's what I'm thinking of right now. And yeah, so that's where I'm gonna put it. So this JevaR engine will implement runnable. And for that, obviously, we need to create the proper classes. So we'd have to add the unimplemented methods, which is the run method. We have to override that. So let's generate some stuff. Before we implement that or anything, let's just have this thread created as well. So it's going to be a private variable called game thread. And once our game engine is initialized and game screen and everything is initialized, we want to initialize that thread as well. So game thread is equal to new thread. And I believe you just want to start it. Game thread.start. So internally, the game engine will handle everything here. And that's going to call the run method. We're only going to have one run method. So let's kind of copy this a bit. So we're gonna need an is running boolean, and it will be false by default. That's gonna be private. Is running is equal to false. And down here we set is running equal true. Now, there are two things that we want to happen every time the game, every time it loops. We want all the game objects or all the entities, we call them JevaClips. We want all the JevaClips to first update themselves, and then we want all entities to draw themselves. So what I'm thinking is, instead of having an update method, I think I'm going to call it tick. It's going to be a tick method. And instead of game render, I'm going to call it render. So we'd have to create that. I'm thinking of creating it on the game's create itself. So, but for now, I'll leave it right here and just think about things. So right now, our main engine controls the list of all the JevaClips in the hierarchy. So it'll be easier to access it right here. So I'm going to create two functions, public void. No, I'm going to make it private because it's the game engine that's going to handle it. Private void tick. This is updating all entities. And private void render. This is drawing all entities. So right now, I don't think there's any ticks to happen. So let's just deal with the render for now. And in the render, well, we already have a function here. It's called render engine. And this is ideally when we want every single frame, we want to loop through all existing entities and render them. So what I can actually do is just replace this entirely. So it's going to be render engine, but I'm going to make it private. And just for conventions, I'll just call it tick engine as well. And inside our run method, we want tick the engine, and then we want to render the engine. Okay, let's see what issues we have. So Java no longer has a render engine because it is, well, it's private. Let's actually run this and see if everything works. So we can see that it does not render everything, unfortunately. Let's go and find out why. So I call start. It enters the run. And let's see if it actually enters the run. We can system out trace entered run. This is just debugging the code right now. And inside a while loop, we will say is running. So you can see that it's not actually entering the loops because nothing here is being outputted to the screen. So let's stare at this code for a bit and try and understand what the issue is. So from ours, it says we implement runnable. We have an is running method that's false at the beginning. We initialize our game threads. We start the game thread. And starting the game thread should call a running function. Start call. So what we know for sure is that a start is called, but running is not being called, unfortunately. Do I need to select focus into the application. No, that does not change anything. Let's take it to our trusty Google search. Okay, so the issue right now is run method not being called when thread is started. Java thread does not call run. And how do you know it's not being called? Simple task below works, so there's no problem creating a thread. Running from within, there's something else going on. So they have a runnable, they have a thread. They say this thread is equals to new thread. Do I need to put this? That could be the problem. Let's see if this code has this in the game thread. So yeah, it has game new thread this. Rookie mistakes. So let's start that and see. And yeah, it's being rendered. Success. And it's also being outputted is running. Awesome. So it's small mistakes, but we're learning. So now we have render and tick happening. And now what do we want to happen for every tick? Well, we want to loop through all entities and we want to call their ticks. So for each entity, we want them to tick. And for that, that means we have to create that method in entities. So in our JevaClip, we will have a public void tick. And inside here, let's just say for now, x plus equal 3. So we should see the game objects going across the screen. However, before we run it, I will discuss one issue that we're gonna have is that we're probably gonna be seeing them dragging across the screen. Let's see. Yeah, so it's as I thought. You see them dragging across the screen. Now, why is that? Well, in our render, all we do is draw everything. So if their position changes, we just draw that new position. At no point do we reset everything. And that's what we need to do. We need to reset the screen. So first thing we need to do is call the screen that we can say clear screen, refresh screen. I'm just going to call it clear screen. So I'm going to have a function, a public void clear screen. And inside here, we'll also need access to, I think it's the game panel. We'll just let them access the context. And context is given in FlevaR from the screen's context. So if screen is the one in control of the context directly, then we don't need to try to get that context like that. We have access to it right here, so we can just call game panel with get graphics. And we will store that in a graphics context. So let's just get this context. We will turn it into graphics 2. I don't think we need to turn it into graphics 2D for what we want, but for now, just to be safe, let's do that. And we're gonna have a rectangle. It's gonna be the screen background. Probably need to import this geometry class as well. And we'd have a screen background that comprises of the entire screen, which starts at 0x position, 0y position. The width will be the game panel width value. And the height will be the game panel's height value. So after we declare that, we want to set the color and we want to draw. So set color and we will draw the screen background. Now the color, let's say that the color is, well, it's the background color, which we hard coded for now. So let's put this into variable quickly. Yeah. So we set the color to the background color and we want to draw the screen background. And now in our Java render, before we draw the Java, first want to clear the screen. Clear screen. We just say screen.clear screen. So first we clear the screen and then we redraw everything. Let's see if that actually solves this. So it seems that it is solving the issue, but it's also preventing everything else from being drawn. And I think that's the problem that we currently have with Sue and the threads and everything like that. And he's supposed to show us how to solve that in the next class. And maybe we can increase the frame rate, well, decrease the frame rate at least, so that everything gets drawn slowly. So that seems to happen. And you can see that it's being drawn. I wonder if there is something to do with disposing the context. I'm not quite sure because I think I actually forgot to dispose of the context in the other one. In the clear screen method. Yeah, I don't think it makes much of a difference. But yeah, so at least we can see that it's being rendered. Yes, we can increment X by 50 pixels. It happens 2 times every second. So we can see that it kind of does animate like we want it to. I'm thinking tomorrow during the lab, so will show us how to fix this issue. So I'll try to fix that as soon as possible. But we have a loop working. So moving on, we can try now to make this is key down feature work. And for that, well, we'll need a key class and we need some event listeners. Let's take a look at how Sue does it. So in the main game window, he implements key listener. He adds a key listener to the main panel, and then the main panel has, well, the key pressed and the key released options. So what I'm thinking is I need to have an entirely different key module that will handle these things. And we'll just kind of expose that function to JevaR. So let's see how far you can get from now. So we have our JevaKey, and it will it's gonna implement key listener. So for that, we'd also need to include the expected interface right now. Oh, where? Do we need to import that? Yeah, so we needed to import the event class and EWT, the event package, in order to implement the key list. So now we have to add an unimplemented method that's key typed, key pressed, and key released. Just like it has it here. Now there's no functionality in key release and key typed, but we're going to add that functionality ourselves. So now what I'm thinking is we want to have some keys like up, down, left, and right as public properties, and those will contain the key codes for those characters. And so when a key is pressed, we can probably get that check. Now this is probably going to be really complicated, so this might be the only thing I get to implement, because I recall it was very complicated in the FlevaR game engine as well. Let's see how far we can go. So the key press is what we're mostly focused on right now. First, we want to get the key code, and key event is kind of what we seem to be interested in, which key event vk.left is, yeah. So what we're going to do, we're going to have some properties called, so public int, because I believe they are integers, left is equal to the key event dot vk left. Same for right, up and down. Just to get it. I'm not sure if there are those for WAS and T as well. Let's see, W. Yeah, VKW works. A, S, and D. So I might probably need to do that for the entire alphabet. But for now, I'll just use WASD, up, down, left, right, up, down, left, right, WSAD, and I probably also want to use space. So is space a key? Yeah, and probably enter. Yeah, great. So those will be some hard key codes right away. What I'm thinking is that we would also need a hash map to keep track of what key is being pressed and what key is being released. So we have a hash map of key codes, and either, well, it will either be true or false, but for purposes of us trying to keep track of what keys pressed or what keys done, but in JavaScript, what I do is I set it to three different states: undefined, true, and false. And based on those values, the game engine is able to handle everything. Let's see if I can show you that. Because I actually created a book, I would say, on how the FlevaR game engine was created. It's a 79-minute read. It's a 1 hour, 24-minute audio. It's like about 18,000 words. What I'm focused on right now is not the game screen, low screen mouse inputs. It's about the keyboard inputs and how it works. So, keyboard input. Yeah, so in keyboard input, we have some APIs like the key.up, key.a, key.enter, things like key.isDown, and all those different things, and that's what I'm going to try to implement as well. So some of these are properties, some of these are methods, and it was influenced by ActionScript 2. So how it works is the game engine has some event listeners when a key is down or when a key is up. So we're going to be using key pressed and key released in our engine. And internally, when the key is down, we get the key code and we store that in the key list, the key code. So the key code is either undefined, true, or false. Yeah? And that's kind of why I want to set. So I'm going to use this as my guide to implement it. So the key down and is key pressed and the key up is key released. We're going to make these private variables since we don't want anyone to access those. Okay. Am I allowed to have it private? It cannot reduce the visibility. Okay, so I can't. So I'll just have to keep it public, but that's fine. So firstly, we want to have a key list, and that's going to be our hash map. And since I can't use booleans for being true, false, or a third property such as undefined, because I think things are false by default, then I'm just going to use an integer with 3 states, 0, 1, and 2. So 0 would be undefined, 1 would be true, and 2 would be false. That's a very strange way to think of it, but we go with that. Oh, I can use -1, 0, and 1. So 0 is false, 1 is true, and -1 is just undefined. Well, it's going to be the representation. So let's go with that. So we're going to have a private, it's going to be a hash map. That's going to be an integer of the key codes as well as the integer of the values states, 3 states. Am I allowed to use integers? May have to give it a name, but we call it the keys list. Okay, so I seem to get some errors. Let's just go try copy pre-existing code, because Java is not my strongest language, so it doesn't seem like I can use integers. Or do I need to import hash maps? Let's try importing. No, so I think the problem is with integers. So let's see. Create hash map of integers Java. Hash map int Java. So I have to use the entire integer. That's interesting. No problem. So in our key, I don't think I want to have to instantiate this. Everything is going to be static. So create static constructor Java. Because if I make it static, then am I able to initialize it? Maybe I need to initialize it as soon as I create it. Initialize static hash map Java. So it seems we can use the static initializer. So let's do that indeed. I'm not sure if this Java supports it. Oh, no problems, no complaints. So key list is equal to new hash map. And in this key list is where we want the different key codes. So for now, let's say, I think I'm going to send it to attributes type. So keys list dot put, and we want it to be code because these are the key codes, plus up, and that will be -1. Let's just, should I use an enum for this? How do you create an enum in Java? That'll make it easier for us in case we need to change it. So enum Java. Okay. So private enum key states. Because there are 3 key states. And we're gonna have undefined. We're gonna have true, and we're gonna have false. But I can't use true and false, so I'll use undefined on, which is true, and off, which is false. Can I declare them? Undefined is equal to -1. Can I do that? I can't. Probably just defining it is enough. So instead of undefined, I call it null. Oh wait, I probably can't use null. Nil. So nil, on and off. So at the beginning, all the keys will be the key state enum nil, key states dot nil. So that means how this property type will have to be of type key states. Yeah. These are some hoops. So it's up, down, left, right, WASD, space, enter. So I'm just gonna copy everything here. And then for all this code, I'm just gonna paste that in. So whatever the key code for up is, if that is 38, then we map the string code 38 to nil. Down is 40, so we map code 40 to nil. So we've mapped everything to start off as nil. And now, when a key is pressed, we want to get that key code, and that key code we will match with our stuff. So we say if keys list the get, I think that's how you get hash map properties, and we want to get code underscore plus key code. So if the up key is pressed, I think that's 38, we're going to try to see if the key list at code 38. If that is equal to key states that nil, then what we want to do is set that to true. Well, set it to on, so the key will be down. Yeah, let's use down, and let's use up. So nil, down, and up. Yeah, then we want to set it to be down. So we have to use put. Polynate. syntax. There we go. So when the key is pressed, if in that particular frame, if the key was nil, then the key list down is, well, the key list is down. To achieve this, both the key codes and key names are stored internally as values prepended by code to help distinguish between the types. If the key A was pressed, we stored as both code 65 and name A. Thus, when checking for an existing key, the appropriate state will be checked. And that's in the isDown method. So we can create that isDown method, but we'll also need to do the same for isUp. And I think the fastest way to check for the internals of all of that is just to check the code on GitHub. So let's look for the JevaR, the FlevaR editor. We're going to take a look at it on GitHub. So inside the FlevaR class, you guys may want to close your eyes for this because it's 8,000 lines of code. It's just one plain file. At least in Java, I'm splitting it up. So let's look for list. So on set key down, which is key pressed, we get the key code. I think they're also able to get the key name, and we could account for that soon, but for now, let's not worry about that. So let's look for the key name, the key code, sorry. And so we have a key list and a key pressed. So I'll need two lists. One for just keys being down and up by default, and one for keys actually being pressed. So let's duplicate that. So I'll have to hard code those things as well for keys pressed. So that's going to become tedious. You see how we could refactor this in the future. So for now, let's take off a lot of this. This is too much to try to accommodate. Well, let's just look at up, down, left, and right. Yeah, so we have a key list and we have a key pressed. And on key down, if the key list was nil or undefined, we want it to be down or true. Same thing for key pressed, I can see here. They also deal with the key name, but we're not worried about that right now. We want to be as simplistic as possible. So, and then in the key up, this is where we have a lot of complicated things. Checking if key is pressed. I can see we're also checking for key release. So that means I'll have to create a key released method as well. Keys released. Yeah, so there definitely are some key released stuff. So we have keys list, keys pressed, and keys released. Yeah. So let's duplicate this one more time. We call it keys released. We want to duplicate this as well. And everything here with the keys. Oops, too much. Everything here with the keys released. The same thing here. keys released. Oh, well, we're not going to have it here actually. So we just have key list and key pressed over here. Now in the key up or the key released is where we first have to get a key code as well. And then inside here we do the magical checks. First, for the key list, if it is true, so if it is down, then we want it to be, well, we call delete here in JavaScript, which I think just, well, we're turning it back to undefined, so we're turning it back to nil. So if key list, the key code is equal to down, then we want it to be nil. And now we want to check for keys pressed. And if that is not nil, then we want to do some magical stuff. So let's get this out. So if the key pressed is not nil, and is runtime started? I'm not really worried about that. Key released is true. Yeah. So that's going to be some magic stuff that I'm going to have to implement as well. So if it's not nil, then we want it to be nil. So if it was anything else but nil, we want it to be nil. That's what it's saying. But before we handle that though, what we're also saying is if the key pressed is a Boolean, meaning if it's true or false, so it's not undefined. So in our case, if it's on or off, which means it's not undefined. So this seems like some redundant code actually in this engine, because I check if it's not undefined, but then down here I try to make sure it's a Boolean as well. But we only have 3 states: true, false, or undefined. Like true and false are Booleans. So that seems to be some duplication. That's interesting. So it being a Boolean means if it either is on or it's off. So it's not going to be nil, because it can only be on, off, or nil. And we already check it out here if it's not nil. So if it's not nil, and if keys released is equal to nil, then what we want to say is keys released would thus be on. Do I have it as on or do I have it as down? True. So what they're saying is if the button is not undefined, if the press is not undefined, that means somehow it might be down in that frame. However, the key released is undefined, so the key has successfully been released. And then we want to check, no, the key release is undefined, meaning there's no state, it's nil. Then we want to set key release to be down. Now this is I can't recall the train of process, the train of thought I went through to solve all these things. I'm just going to be replicating this code. It seems like there's some duplicate code, or I'm not seeing things properly. So if key model, that's key press, is not equal to undefined. Oh yeah, this is the duplicated code for the key name. Yeah. And then we do something else with the keys. at another point in time. We clear key states. So I also need a clear key states method. And we want to loop through our hash map. Let's just go back to the main and copy this code because to loop through hash maps. We're looking at all our key pressed list. So we're looping through the hash map for key pressed. And it's going to be a key. We want to loop through each of them. And then for all the key pressed, if the key press is true, we want to set it to false. So in this case, if it's down, we want to set it to up. We don't want to set it to nil, we just want to set it to up. So let's have this constructor and see what this is. So this is the title and this is the key state. Loop hash map and change all Java. So we're looking at the key. We can use this main key. Okay, I think I see how we can do it. So we have to call keys pressed dot put at this key value, and we want it to be key states dot up. And that's only if the key, which is the key state, is equal to key states down. I think that solves the issue. So here we say we loop through it, and if the key pressed key is true, so we say if that key state is down, just true, then we want that value to now be false or up. Then we're gonna have another for loop, and we're just gonna set all the key released to be nil. So we loop through the key released, and we just make all the keys and key released be nil. This is actually a key state. So I'm just going to properly label this so that we will get mixed up. And this is actually the key code. Yeah, let's mix up those things. Okay. Now, finally, we're looking for an absolute. And if absolute is true, then we also clear this. So it seems to be a boolean that it's absolute. And if absolute, then we also want to loop through the key list. And we delete all of these, meaning we make them nil as well. Yeah. Let's see where this clear key states it's being used. So it's used in the run engine, as expected. It's used, that's if a key object has been selected. That makes sense. And it's used below. And it's used for selective order. Okay, yeah. And then for expired key presses, it's used when we use a scene. We want to expire the previous presses. And when we reset the scene, we want to expire the previous key presses as well. So it seems like we set key press to be expired. So let's create that function in advance. Public void expire key press states. That's just so when you look to press a key and then you switch over to the other string, then it will just reset for you. And it kind of makes sense now why I have that function above checking if it's a Boolean. So I guess key press had 4 states. It had undefined, expired, true, and false. In JavaScript, you can easily change data types. So in Java, I only wanted to check if it's on or off, which would be, well, up or down. So let's go through that. We're going to loop through all the key press. And we're going to make it expired. Obviously, we need to include that in the key state, expired. And let's go back to checking when the key is down. So set key down and down here. So that's why I say if it's a Boolean, then we do that, because we don't want it to be nil and we don't want it to be expired. It'll only be up, but it'll only be down. So inside this variable here, this will only be entered if the key is not nil. So by process of elimination, we also wanted to check if it's not expired. So if it's not nil, and then if it's not expired, meaning it can only be up or down, process of elimination. I can also do if it is up or if it is down. So just to prevent future headaches, let's do that. So if the key is equal to up, or if it's equal to down, meaning it's a Boolean in this case, and then the key released is undefined, then we want the key released to be down. Yeah. So it seems like all the key stuff should be working. Clearing key states and all of that as well. Yeah. So now let's go to implementing the is pressed or is down or is up in the keys. So those are going to be some public functions that we can create higher up. So public Boolean is down, and they're going to pass in a key code, and that's going to be an integer. I keep forgetting in Java you have to put the data types a lot. Then we need to return a Boolean, so we'll assume. So Boolean key down is equal to keys list dot get code underscore plus key code. And when we get that, we want to see if that value is equal to the key state dot down. I'm going to return that value. So let's think about this for a while. And the is down. We want to see if that key state's current value is down. So when we check, so we probably call the function saying key that is down 38, and the key code will be 38. And at that particular frame, if through the key presses 38 was down, then in the key list at position code 38 would be key state.down, because we did that in key pressed. So we take whatever code and set that key code to be down. I think I'll have to have a check to ensure that we do have that value, so we don't create values that we don't have, in case they press W, because we don't have W as a function in Java. So it will give an error. And then when the key is released, then that key code will not be down, it will be nil. And here we're checking if that key code is only down. If it's down, then it'll be true. Otherwise, it will be false. So now public Boolean is up. We also want a key code. And let's just return the opposite value of is down. So it's kind of like the inverse, because if it's not down, it'll be up. So rather than having to code that, we just have the inverse there. Now where things get a little more complicated is the is pressed and is released. Because rather than handling the event listeners, we're kind of trying to make this our form of event listeners on every frame. So that if it's 10 frames per second and the first frame you press a key, then in our code right now, we set the key list, so the key will be down, and then the key pressed will be down as well. So in here, what we want to do is we want to capture that the first time the key pressed is down, and then instead of setting it to undefined, we want to set it to be something like or up or off or expired or something else. What I would essentially do is inside this key pressed down, every time that key is undefined, we set it to be down. So, but we only want that to capture once until the person releases the key. So it's kind of going to be like a flag. If you press it down, then every single frame, it will capture the first frame and then set it to something like we want to set it to some other value, and I think it's somewhere in the code where I clear the key states. Yeah, so I clear the key state, and for every key pressed, if it is down, I'll just set it to up. So the first time it was down, it'll be captured in the code. And then on the next loop, everything will be cleared and it will be kind of seen as up, but it wouldn't be nil, so it wouldn't get pressed down again from the event listener. So that's how we only make it happen once. And then when the keys are released, if the pressed was not nil, meaning it was up or it was down and it was now finally released, then it will make it become nil. So that the next time it's pressed down, the first time it happens, it will turn from nil to down. And then on the next frame, it will kind of reset it to be up, but it wouldn't be nil, so it wouldn't be constantly feeling like it's been pressed. And it's the same process to go on with the key released. But let's just implement this is key pressed. So what we want to do is return the key down for, well, key press for this thing here. The key pressed, and we're looking at the key pressed function. So if the key pressed is down, then it'll be true, then the key was pressed, otherwise it'll be false. And we handle that in the game engine itself. And then finally, our Boolean is released. We also have the key code. It'll be key released and key released. And inside here, we just use down, but it's kind of it being true, as in it truly was released, stuff like that. So it seems, and all the other stuff is kind of to handle it being a word or a code or whatever. So we're just using key codes for now. The things. Okay. Yep. So now before we implement this, we have to go back to the run engine, because in this run engine function, we can see before we tick the entire engine or before we render the entire engine, we first clear the key states. Oh wait, no. Well, that is if we have a FlevaClip selected. That's a functionality I have in this current game engine. So what we do is we tick the game engine, then we clear all states, and then we render stuff. So if the key was pressed at a frame 1, it's going to be down, and it's going to be handled from down, from the event listener set it as down. It'll be captured here, then it will be cleared here. So that even though it's being held down, when everything runs and it goes in the second frame, it's not going to be seen as down. It's going to be seen as like up or some other value. And then when the key is finally released, then it will be reset to nil. So when it's pressed again, it will say, oh, it's nil, let's put it down. And then the clear key state will put it to up, but that's not a value that sets it as down. It will only be set to down if it was nil. Whereas the is down will always work, because the key list is down would be true as long as that key is being down, and then when it's released, it come up. So the key state doesn't refresh that. So in our JevaR run engine, we want to tick the engine first, then we want to call key, I think it's JevaKey dot clear key state. Maybe I need to make this a public variable. So I think clear key states is public. Oh, we probably just have to set true or false. Let's just send it as false. Cannot make a static reference to a non-static method. Oh, we just need to make everything here static. So I think that's where our problem will be. We would need to initialize static method cannot hide the instance method from key listener. So we can't make key release and key press static. So we need to kind of initialize this this module if we want to use it. But maybe if I can control that initialization, then it'll be beneficial. Or I'll just have to handle it an alternative way by making everything static. And making something else implement the key listener. So let's go back to source code. His game window, again, implements a key listener, and then so does the main panel. So we can copy something like that. His main panel adds key listener. So in our game engine, let's actually do the implementing of these things. Oh, yeah, let's start with that. Let's have this. So we also need the key press, key down, key up to be handled in the key launcher. And of course, key event may need to be imported. And these variable names need to be accessed as JevaKey dot list. Let's just make this public to prevent these issues.
He will talk back up at the left and at the help. And skip with the occupied to come again. The physical difference, the request. Should stop. But the fact that back, but the fact that it should tip at the plug was the fact I should have put the plug. But all of the goal.
So that should do the trick. And now in our game application, we should be able to run this code. It's JevaKey cannot be resolved. We probably need to import it. Import code JevaKey. And the Java that attached JevaClip should also return that JevaClip so that we can use it. So this will be public JevaClip. And we will kind of be returning the JevaClips.
Stood. I'm happy. Nothing. I should have it. Stop. How wise. The chat.
Okay, so it returns a JevaClip. And down here we want to check if that JevaClip is not null, but what we want that to be in is inside a kind of a tick method. So for now, what is the best way we can go about doing this? We can go about doing this looking to add scripts because we're looking to make it a lambda function. So Right now, this script does not execute on loop, and that's what we need a lambda function to do. So let's go to our friendly Google Pal and see how lambda functions are added. So we can create an interface callback, have a type of code, and run that method. Okay, so I think I understand how to do it. I'm gonna create something like a script. So I'm gonna call it script, JevaScript. And it's gonna be an interface. It is going to be an interface. Public interface, JavaScript, and it's gonna have a all method. And that's all we need. So that's gonna be the JavaScript. Then in our somewhere in our code, like an add or an execute script. So we're gonna have a list of scripts on our main game engine. And that'll kind of be like holding the method, because we're gonna be executing that internally. So let's have a private hash map string that's also gonna use a UUID. And is it a JevaScript? That's gonna be scripts list. Let's initialize that as well. And we'll have a we'll have a create script to add it to the library and use script. But for now, let's just have an add script function. So public void attach JevaScript, and that is going to take a JevaScript script. Now inside here, we're gonna put it in the list. So let's just see how we created some JevaClips. So we create a unique ID, and we will take the script list. Let's rename this actually. JevaScript. Entire JevaScripts. Hierarchy. And we're gonna put this script in that hierarchy. You're just gonna store that JavaScript, which are lambda functions. And then finally, inside the tick engine method, what we want to do as well is execute the JavaScripts. So for example, if we look at our FlevaR tick engine code, what it does is, well, it does a lot of stuff. But then it first executes the scripts in its list of scripts. And then it loops through all attached FlevaClips and execute their ticks, which will execute their script. And then finally, every scene, it calls that tick, and that scene tick will execute its scripts and then call the FlevaClips ticks, and those FlevaClips will execute their scripts. So yeah, inside here, the first thing I want to do is loop through all the scripts, execute, run all engine scripts, run all attached scripts. So we have a JevaScript hierarchy. It's going to be the unique ID that's not important, as well as a JevaScript. And what we want to call is script dot call. Yeah, script dot call. And that should do the job. So finally, what I can do, so first let's take this post JevaClip and store it. So JevaClip, JevaClip SQL to JevaClip. Probably I need to import this as well. And then this entire function here, this code will be in a script. So we can say JevaR dot attach JevaScript. How to what else that? And this script inside here is gonna be a lambda function, and this lambda function, well, we can pass something to it that it should be expecting. So maybe I'll need to define that under call. It's gonna accept an object self. So the game engine will have a script with this, and this will represent self. So I can create an enum of all the things it will accept and then modify on, but it just calls an object now. And then this JevaClip will have, well, it's gonna have JevaSelf property. Is this, are you not satisfied? Jeva, capital R. Yeah. It's not attack, it's attach. Did I incorrectly name this? What is your problem? The method attach JevaScript in the type Jeva is not applicable for the arguments JevaSelf. So how do I solve that? Now that's a good question. For now, let's just put everything inside here. And then let's try and fix this. So if we have nothing, there are problems. We have this, there are problems. Here, JevaScript, import JevaScript. Yeah, that would also be a problem. What happened? Self? Oh, that's very interesting. Well, that's what I intended for to happen in any case. So Jeva that attached JavaScript, it'll accept itself, and then we do some functions here. So when we attach this JavaScript, it's going to be added to the JavaScript hierarchy, which should be executed on every tick. So now our code here is we're taking the first JevaClip, and if the down key is pressed, it should go. I mean, left key is pressed, it should move left, and if the right key is pressed, it should move right. Let's see if that works. First I'm gonna go in with JevaClip, and in the tick method, I'm gonna move that away a bit, because this tick method will just be calling its scripts, as can be seen here. If I have a tick, yeah, so in the tick here, in the FlevaR clip, it just executes the scripts that would have been added to the FlevaR clip. And we'll get to that soon. But for now, let's just execute and see if this works. So if the left key is down, it should move left. And if the right key is down, it should move right. Let's see. Left. Right. And as you can see, it does not work. So now we go to debugging. First, let's see if it's being called every frame. So in a JevaClip, we can say system.out.println script being called. So the script is indeed being called. And now one must ask the question, is the key down being successful? So let's try to output that. JevaKey dot left. That should give us 37. Okay. And now in the JevaKey that is down check, let's just system print a key code. So we'll see what is here. Check. So it's checking for 37 and 39, which is the left and right keys. So this function is being called. And oh, I think I know what I forgot to do, because in Sir's code, he added the key listener to the main panel or the game panel. In our case, we have not done that. So let's go to our main, and it's inside his constructor with the game panel, which in our case, the game panel is inside a screen. So we should want to add these things in our screen.
With the platforms.
So we add the key listener. And for that, I think we should put the key listener inside there instead. So yeah, you can see a lot of refactoring and manipulating things being taken around. So the game screen will handle keys being pressed as well, since it'll need access to that game panel. And we'll also just call that, put it there, and hopefully adding the key listener should do the job. So main panel, add game panel, main panel, add key listener. So we want to add the sub panel first, and then we want to add the key listener. Well, let's do that. So game container will add the panel, Oh, it actually did not matter. So it probably should not matter. Let's test it out. Let's see. Let's see. So if a key is being pressed, we want to output key being pressed plus E dot. Well, that's the key code. So that's just for testing purposes. And inside a JevaKey, let's remove that, essentially that works. So key being pressed is not being detected on an application. Let's go back to our screen and see what if we put the key listener above. Would that make a difference? Or should it be on the, well, yeah, it should be on the JFrame, which is what we have it as. But it's still not being detected.
Yes.
So their game window is JFrame. It implements the key listener, and it's been attached to the game panel that has been attached to this stage. And we have as well, you have the game panel. We added the key listener, and we are surprised by the fact that it does not work.
What?
What is their main panel? Their main panel is a J panel with flow layout and all of that stuff that we don't particularly need. I don't see any reason for it not to work. Do I have to request focus or something? All right, let's just see if there's words. So if a key is pressed, then let's output key being pressed.
We both. That's for that.
Oh, so it needs to have some focus first. And that's on the focus on key text. So it's on focus button. And we say main panel.request focus. So we kind of need to request focus on. We can do that in constructor.
Plot.
Game panel.request focus. Okay. Let's see this was. Nope. Maybe it needs to happen after it's been added. It's not being purged. It means after it's been visible. It's finally being pressed. Yeah. So there you go. I guess I needed to request focus after the panel has been visible. And as you can see, as the left key is being pressed, it's going to the left. And as the right key is being pressed, it's moving to the right. Whoops. Let's increase this FPS just to further test this. So on run inside here, we have thread sleeping for 500 milliseconds. But I wanted to sleep at the particular FPS. So if I set FPS to 2 frames per second, then it should sleep 1000 milliseconds divided by 2, which would be sleeping every 500 milliseconds, which would mean every frame in 2 seconds. If I wanted it to have 10 FPS, 10 frames per second, then it should sleep 1000 divided by 10, 100 milliseconds, so that it'll give me 10 frames in that second. So we can have a function for that as well, and we can implement that right away. We'll have a private FPS function. It's going to be an integer. We can accept that FPS function as well, that FPS parameter in the constructor. Or give it a default. So we will create an overloaded constructor that will have the FPS. And by default, we just set an FPS. So inside here, we call this the width, height, and a default FPS of 10. So that, and then inside here, we will say this.fps is equal to PS. So either the person will initialize the engine and give us an FPS value, or it'll use a default FPS value of 10. And then in our run method, we want it to sleep for 1000 divided by FPS. 1000 milliseconds divided by how much frames we want, so that we get that amount of frames per second. So now in our game app, let's initialize it to 5 frames per second. So you can see it's moving around. Again, it flickers like this because I'm using the limited code that Sil had with the flickers. So once we fix that in the lab, I'll also fix this code here. I can probably remove the key downs now. If I was to change this to is pressed, so if the key is pressed left, then go back. So what I would do is, no matter how many times I hold down the key, then I'm holding it down right now. As you can see, key being pressed down there, but it's not moving anymore because the is pressed was fired off. And now I first have to release. You can see key being pressed, not being triggered anymore. And if I press it again, then it went across once more. If I release again, I press, then it goes again. So I need to keep pressing. So that's how that press function is, with the clear state and all those different things. And same with released. So let's go across right for a bit for you to see. All right. So if I press it, nothing's happening. Key's being pressed. But if I release the left key, my finger goes up. You can see that it goes across once, and it doesn't go across anymore. If I keep pressing it again, and then I release, it goes again. Pressing it again, release, it goes again. So the key press and key release successfully works in a continuous script of code when you run these is release functions. It gets captured at the first frame, and then it doesn't get captured again until you either release and then press again, or press first and then release again. So those work successfully, and it's done. And we can do the same for the right and left. Else, if JevaKey that is down key dot it's JevaKey dot up, Then JevaClip dot y position minus equal 30. Else, if the down key is pressed, then JevaClip dot y plus equal 30. So let's just comment all these are the JevaClips that we can't control at the moment. And now we have a JevaClip that can move left, right, up, and down. We can probably remove some of these else statements to have more fun with it. So you can move around diagonally, and we kind of have a moving character in the screen. Yeah, and it works.
And we'll get to square bit.
It's awesome. I think the only thing I don't like is the FPS being how it is. So at 10 FPS, it can't see anything. Probably at 30 FPS as well. Yeah, 30 FPS, it can't see anything either. So I keep it to the minimal of frames per second for now, until Serve fixes that issue. And then we'll have a consistent flowing game. Well, yeah. Ways to extend this now would be having to. I think it will probably crash if I press some other keys. Oh, it doesn't seem to crash actually. Oh, I think it because it takes any key and it puts it in the hash map based on the key code from our function that we would have done on the screen. Yeah, if the key is pressed, we try to get a code, and if that code doesn't exist, then there's nothing to prepare.
Like it.
So yeah, what we can do to initialize some of these things without having to hard code it. So in our JevaKey here, we hard coded a lot of values. And set them to be nil. So it's only checking for values that are nil. So now it won't work again because we moved them from there. But what we can do is if the JevaKey is equal to nil, or if that key list is equal to null, meaning it does not exist, then it should be added. And then from there it'll be set to nil. I think we can do the same for key pressed. Then in key released, we want to check if it is nil or if it is null. Then we want to put it in the hash map. Let's actually see if this works to begin with. Yeah, so it works. So now no matter how many keys that we've added, they will all be added to that hash map, and we didn't have to hard code that. The only thing we still have to hard code kinda is the properties at the top. So these properties here, because these static variables, because we want these to be the character codes that are easily accessible. So for example, if the key is down, left, right, up, or down, but if I wanted to change this into W, A, S, and D, I'd have to use the code. So left is A, right is D, up is W, and down is S. So now if W, A, S, and D is pressed, and as you can see, so A has the key code 65, and you can see key press 65. D has key code 68, and you can see key press 68. S has key code 83, and W has a key code, I think, 87. And when I press, you can see that 87 was being held down. So, and that's only because we stored these values. Obviously, I did not store a value like E, so you can see that there's no value called E. I'd have to come in JevaKey and say static int E would be the key code for V key E. I think like probably instead of calling those things, I can just use these directly. So key event, obviously I will have to import that. And we can see if key is down VKE or VKZ. So if VKZ is down, then we want the FlevaClip to go left. And Z's key code 65 plus 26. Is it? Let's use a calculator. So 65 plus 26 letters in the alphabet. 91. But I think 65 was E, then Z will be 25 more letters instead of 26 letters, so be 90. So the key code for Z should be 90. Let's move our cursor right first. Now let's press Z and see if it goes left. And you should see down here, it should say key being pressed at 90. Yep. And it's moving left. But the only problem with using key event is that you had to import another package, Java AWT. Whereas I want them to be able to just import Java core JevaKey and be able to use JevaKey.z. So at least for now, I will have to manually do that. Let A, B, C, D, E, F, G, H, I. Okay. Let me fix for the letter Z. And now here, Z would also work because it would have the key code. And yeah, it goes up the screen. So in a simple game where you want the player to be able to go up, down, left, or right, you just have to do some ORs here. Because if you want them to either use the left arrow keys or W, A, S, and D, it's just a bunch of if statements. So if A is pressed or left is pressed, move left. If D is pressed or right is pressed, go right. If W is pressed or up is pressed, then go up. And if down is pressed or S is pressed, go down. So plain if statements. And in here, you can see I'm using 39, 40, which is down, 37, which is left, and 38, which is up. And then I'm also using 68, which is D, 83, which is S, 65, which is E, and W, which is 87. Yeah, and that so both sets of keys makes you move in the directions. I'm thinking numbers may be confusing. Let's look at getting the key text. So for that, and is it in? I think it's in JevaScreen. Oh no, let's copy that. Rather than key.getText, this is use key event of getText. So the key being pressed will have a key code as well as a key text. So the code is equal to key code, and the text is equal to the key text. If we press left, you can see code text is left, right, up, and down. Now let's hold them down to see. So the character is moving down and up. And similarly, if we press A, it goes left. If we press D, it goes right. If we press S, it goes down. And if we press W, it goes up. And all these other codes can be pressed and detected successfully, but they won't do anything at the moment. So one way we can extend this to check for letters as well is by using the key text actually, and that's what FlevaR does. So, well, firstly, it sets everything to lowercase, so you won't have to accommodate for these capitalizations. It just sets everything to lowercase. So let's go about implementing that as well. So similar to FlevaR, the key codes right now is code underscore and the key code. So that way it would not clash with the key text, like left, right, up, and down. Because in the book I was using here, you can see that I described the use of codes and names. And if the A key was pressed, it would be stored both as code 65, which is what we currently store it as, code plus key code, which is 65, and name A, which is name underscore, and then the lowercase text. So we can mimic some of that behavior as well. So the key text would be getting the key text, and then we want to lowercase it. I'm not sure if, yeah. So Java also has a to lowercase function. Let's just keep printing that out to ensure, yes, so all the words are now in lowercase and all the letters as well. So that's great. So we will mostly have to, I'll leave this up here for now. We mostly have to duplicate this code because as you can see in the key engine as well, set key down, you can see the code was duplicated for the key code and key name. Key code and key name. And we set those values above here. So we can do the same on top here. So key code would be code plus the key code. It's going to be a string. Oh, I think I'll also need to store. So what I'll do is the key code is the code. So for now, we leave it as key code. And then we also have a string. So string key code text, I guess. And that will be code underscore plus key code. And then the key text, which I will call it name. So this will be code. This will be key code. That will be key name. So key code and key name. Kind of trying to be consistent with the JavaScript. Load. It will also be name underscore plus key and name. Right. And the key code is what we'll be having here, because that's honestly a lot of duplication. So we have the key code, and we also need it for the key name. So let's duplicate this for the key name. Let's format that. Readability. And the same here. Readable. So for each thing, we store the code representation and the string representation. Let's just kind of make sure that we're doing something correctly. So when left key is pressed, it's stored as a key code. So when left key is pressed, so that's code 39. Oh, I mean the right key. I'm a sleepy. It's code underscore 39 and name underscore right. Same thing with left, same thing with down, same thing with up. And so that's also happening for pressed. Now for key released, which is set key up, we kind of need to do the same thing with the key code and the key name. So it'll make working with the code a lot easier. First just chooses the code. I tell you just choosing there. So for key code, you just do everything again as it should be. Okay. And now we'll have to duplicate all of that for the key name. So here there's key code and key name. Then this entire if statement with key code and the same thing, but instead of key name. So it duplicate this, and it's key name, and then this entire statement duplicate it, and everywhere that says key code, we have key name. So now when we query the value, we'd either look for string or an integer. The integer will be the code, the string will be like a label. So I think we need to have some overridden methods, and those will be on JevaKey. So if it's down and it's an integer, it's going to look at the code. Otherwise, if it's down and it's a string, we're looking for key name. So we can tell this it's just key code. Then we're looking for name underscore key name. So like if they say if key is down, open quotes left, it'll look for that particular thing instead because it's a string. So we can do the same for the others. If the key is up, and they send a string, we are going to look for the opposite of is down with the string. If the key is pressed and they send a string, then we want to look for name underscore that key. And if the key is released and they send a string, then we're going to look for key name and name underscore. So that should solve it. Let's go to our application, and instead of saying if key is down A, let's say if key is down O. One more thing, I want to lowercase those keys over, because right now if I use the key name A, then it will work. I think let's go across to the right a bit, and now let's press A. So you can see name A is being pressed and it goes across successfully. Down here, name A is being pressed. However, if I do capital A, because I lowercased all the hash map values, then it would not be affected because I only stored the lowercase versions. So what I'll have to do there is first lowercase this variable here. So it's going to be a string, and we look at the two lowercase version. So everywhere there is string key name, I'm just going to try and do this multiple times. So that's 4 times. On the line right below, we want to say key name is equal to key name to lowercase. So it becomes lowercase. So even if you pass a capital letter, it'll check for the lowercase version. So even if I pass capital A, it should still work because it will look for the lowercase a. Let's move this FlevaQuick over to 200 pixels. Yeah, if I press capital A, it's still going to go across because it's going to be detected as undercase name as intended. So we can see this key function handles hard key codes as well as letters. So that'll work as well for it. So if JevaKey dot is down space, is it space or space bar? I'm not quite sure. Then JevaClip dot x is equal to, let's say, half of the screen, 300, and JevaClip dot y is equal to 250. And instead of it being down, is pressed. So if the key is pressed, if the space key is pressed, I want to reset the position back to the center. So if I press space, it's kind of in the center. Well, the x and y coordinate is in the center. Obviously, the JevaClip is being drawn at an offset there, but the x and y feet in the center, which is what we intended. So we can move it at any point, but as soon as we press that space, it's gonna reset. Yeah, so that's successful. And we could have either used space like that, or we could have said JevaKey dot space, which would use the code instead. So if we press space, it uses code 32. So anytime that's presses code 32 or namespace, and we either capture it by the code or we capture it by the word. So yeah, we have a very good functioning keyboard listener, and this is going to be very useful for the rest of our stuff when we're checking what key is down as well. And we can use as many strings as we like. So right now I'm feeling too lazy to go implement the entire alphabet as well as all the numbers and all the other stuff. So I'm just gonna let's see the documentation of FlevaR. In the key module, you can see that I put the code all the way from A to Z. That's key code 65 to 90. I put the code from 0 to 9, which is key codes 48 to 57. I put the Alt key, backspace, the caps lock, Control, Delete, down, the N, Enter, Escape, Oval, Select, Left, Page down, Page up, Right, Shift, Space, Tab, Up. And then I have all the is down, is pressed, is released, and is up. And we have these things successfully inside our key module. We have some of them duplicated just for the purposes of overloaded methods to handle both integers and strings. In JavaScript, how FlevaR would have done it is down is that's the mouse. Is just check. So if it's in the key list being code plus key, if it's in the key list being a name plus key, then we want to just return true. Otherwise, we return false. Now, obviously, that's because any data type could happen in JavaScript. So that's why I just needed one function. In Java, I can't use any data type like that, so I had to split it up into two functions. And yeah, here you can see that I have the alphabets with all the letters and all the key codes. Same thing with the digits, 0 to 9, and then a lot of different key codes. So what I might do off screen is actually just implement all the hard-coded key codes for those different functions. And if it's not a key event, then I would just fill it out here. So I'm going to do that now, and I'll come right back to you. There you go. So you can see that I have all these different codes, 0 to 9, and the entire alphabet. So developers have lot of different letters that they can use, or different key codes preset that they can use. And if they're not satisfied with that, then they can go ahead and take their best shot at the letters themselves. So yeah, the documentation as well, all these letters, the representations, well, should be in Java as well, because these are what they are in JavaScript. So yeah, you can even call raw numbers, because it all comes down to the key code. So if you know the key code for the A key, which is 65, and you pass a key code 65 as well, then that checks for the code 65, which is the letter A, and you can see that it still moves across. So yeah, it's a very dynamic key function that we've created. And in summary, we've created a key function, a very dynamic key function, and we've also added a type of loop, or a lambda. So we have an attached JavaScript, and then every single frame, this code will be executed over and over and over, because this JavaScript is a lambda function thanks to this Stack Overflow call that we had in here. Internally, the engine stores that JavaScript in a hierarchy, and then in its tick method, it loops through all the scripts and executes them with this. Now for FlevaClips as well, or JevaClips as well, I also want to give them their own script to execute in their hierarchy and stuff like that. So I'm gonna move on to doing that next, but I'm thinking like graphics and sound will have to be in a later recording. And that's because this one is almost going on for about 2 hours now. So let's just make the create script as well, and being able to attach them to JevaClips, so that we can code with the JevaClips and see what complications that we may run into. So along with a JavaScript hierarchy, we need a JavaScript library. And we also need to initialize that. Along with create JevaClip, we want to do create JavaScript. So I'm just going to copy this function. Create JavaScript. It's going to have a label, and it's going to have a JavaScript script. So first thing we want to do is we want to check that JavaScript library. If that JavaScript by that label already exists, don't do anything. Otherwise, we want to initialize a JavaScript. I think as an interface, I probably don't need to initialize anything. Oh, I certainly can. And inherit a call. But the call will basically be the script that is being passed by the developer. So we can just use this script directly. And yeah, so we can use the script path directly instead of having to create our own script. So we will just have you just have to add that script to the library. There you go. So it's as simple as that. Add JevaScript to game engine. And now when we're attaching a JavaScript, there are two things. Either attach a JavaScript by a label, or we want to attach a JavaScript that's new. So we're either going to attach a JavaScript that already exists in the library. So it's kind of like you're going to create a script once and then add that or use that script in many different components. So we have to duplicate this attach JavaScript method. And this one will hold a string called label with the label of the script. So it's formatting things. So we can do all the creations on top, creating a library, flubtivs, jobtivs. I think in FlevaR, and if you check the documentation, I have, let's go to the top. Documentation, conventions. I have this flubtiv word, which are the built-in object types native to FlevaR. So they include prefabs, text fields, scripts, scenes, sprites, sprite-sheets, graphics, details, sounds, etc. So all these things are called flubtivs, or FlevaR native objects. Objectives native FlevaR. So I'll call them jobtivs, Java native objects. So jobtivs, flubtivs, jobtivs. Creating library jobtivs. So we're going to create all the native stuff like the JavaScripts, the JevaClips, and all that stuff. And now this section will be for attaching jobtivs. So attach JevaClip, attach JevaScript, and copying what we have from before. If we have a label alone, we try to get that existing script from the library and use that script. Otherwise, we have to create our own. So if we're going to use the label, then first we have to say JavaScript is equal to JavaScript library that get. So we're going to try and get it from the library. And if it's null, meaning that it doesn't exist, then, well, we just want to return, but don't want to do anything. Otherwise, otherwise we just want to attach this script. Yeah.
And then
so if they send a string, we check the library for it. If it exists, we just want to attach this script because we obtain the script and we want to attach it, which will generate a unique ID and attach it to the stage. Otherwise, just return and do nothing. So that allows us now to say create JavaScript. We're going to call it my cool script. And then we're going to pass the lambda function, which is the JavaScript. So this is us adding it to the library. And now we can just say java.attach JavaScript, and we call it my cool script. And now the powerful thing about this is we've added it to the library. Let's just actually test to see that it works. So if I press left, you can see that it moves. Yep, everything moves as it should. And the powerful thing about this is if we duplicate this, so we've added 2 copies of this script, that means every frame it'll execute twice. So instead of the x incrementing by 30, it'll increment by 30 from this script, it'll increment by 30 from the next script, meaning it increments by 60. And that's just because we have it on this one screen. Let's see. Yeah, it goes a larger distance. If we add it 4 times, it'll increment by 120, or this code, which you can see that's a large jump. So that's really cool, and that's really fun. And if we wanted to do more crazy things, we could have put that in another script. Or if we did not even want any of these scripts to begin with, and we wanted a new script. So Java that attach JevaScript. And if we didn't want a script from the library, we just wanted a raw script directly, we can just have that script right away, and we can say something like, so if JevaClip is down, space, reset, 0, 0. This will be R. So let's just copy this. Let's just undo all of that and paste it here. So in our first script that we've also added to the stage called my cool script, we can move left, right, up, and down. And when we press the space button, then it goes to the center. And in our attached script that we dynamically created, if the R key is pressed, then it goes to the top left corner of the screen. So now all of this code should be functioning together. So when I press left, it moves left. When I press right, it moves right. When I press up, it goes up. When I press down, it goes down. If I hit space, it kind of goes to the center. And finally, if I press R, it goes to the top right, because it executes the script as well as the script, because they're both in the hierarchy, so they will both be executed. And it becomes very powerful with this now. Now, what I'm going to try and do is add JavaScript to the scene, to the FlevaR clip. And one script will be there for loading. So when the FlevaR clip is loaded, what it will do, and then it will have an addScript function, which is what will be executed on every frame. And then if we have 2 JevaClips at different positions, but they both have that one script that says if keys down, move left and right and stuff, you realize when you press the keys, both of them seems to be moving left and right and up and down. So let's aim for that. So a new thing we want for the JevaClip when we create it is we want to label an X, Y with a height and an unload function. And that unload function will be executed once. That will also be a lambda script function. So in the create JevaClip, we also want a JevaScript, and it's going to be an unload. So that's going to be the name of it. When we initialize JevaClips, we also want to send that unload function. So now let's go modify our JevaClips to handle that. It's also going to have an unload function. Now it's going to be a JevaScript unload. Okay. When we attach the JevaClip, it possibly would not have an unload function. So the unload function could possibly be null, or it could exist. Let's also extend the functionality. So it will either have an unload or it will not have an unload. And when it does not have an unload, it will just call this with everything as well as null. Yeah. That should not break too many horses. And the cool thing that I'm thinking about this is that upon initialization, in the constructor, we also want to say unload.call. Will it not work? Call this because it's an object. At a later time, I'll leave the calls inside an init function. And when we're reusing a JevaClip, we also want to reuse its unload method because that's what FlevaR does. So we see how things are starting to become complex, but let's not overdo it for now. So on what we want, when we create a JevaClip, we want that unload function to be stored. We don't want it to be executed. It will be executed when the JevaClip is attached or when it is loaded from a seed. So we'd have to store it instead of executed right here, because that's not the desired goal. So let's have an array list. Since it doesn't need like an ID, let's just have an array list. So private array list of scripts, and just initialize. We need to import that as well. Import java.utility. .all. There we go. On initialization, we say script equal to new array list. It's going to be an array list of JevaScripts, if that helps. Okay, cool. So it kind of like gives it a data type, right? Then when we have an unload, we will say scripts add unload. And we will also need to have a private void init function that initializes the variable, and we will loop through the array list. So I think it's for JavaScript script in scripts, and we say script dot call this. So that init is not being called just yet. Let me make it public. Yeah. Or I'll make it protected. I think I'll make them protected because I don't want the developer to call it, but the other game engine objects should be able to call it. So let's test it out. Let's make it private for now. And it's going to call all the scripts inside here. When we are duplicating a JevaClip, we get that JevaClip, we get the load method. And we'd also want to get the script list. So we will say And now it's private, so that's the problem, that is private. But if we say it's protected, then it works. And that's also odd. Meanwhile, we would not be able to say JevaClip.script because it's protected. If it was public, then
Okay.
yeah, so if it's public, it's accessible. If it's protected, it's not accessible here, but it's accessible in this directly. So I think that's what I need to do. I need to make a lot of them protected so that they can be accessible in the game engine, but not in the front end, not where the developer is creating the code. So let's continue looking at this. We're going to copy the scripts. Although I think it's only one script that we need. In the FlevaR game engine, you can add as many unload scripts as you want and it happen once. So if you create a JevaClip and give it an unload script, that'll be stored. And then when you attach JevaClip, if you give it another unload script, it will execute the stored one and that new one. So we need some type of way of extending that. Because if you want to give certain ones different functionality, you want to give them some different unloaders. What I'll make it do is accept either one unload script, no unload scripts, or an array list of unload scripts. So it seems that we can use arrays that as list, and it takes fixed size list. What's the difference in an array and a list in Java? Okay. List is an interface, array list is a class. Do I need to import it? That is so strange. I needed to explicitly import it. Yeah. So if they send nothing, then we do not have any scripts. If they send one script, and then, well, we can just store that one script in our scripts list. And if they send a lot of them, that's what we're going to use. So there are 3 ways to initialize it. So now we make this a list. We also need to import, explicitly import list and send that scripts list as well. When they explicitly have a function, that's if they want it, so we have to duplicate this for sure. And this snippet of code will not accept an unload. However, this snippet of code will. I'm noticing a lot of duplication, but that's fine. So if we want to get that JevaClip, we want to get that JavaScript. Oops, no problem, stuck. And we'll have an unloads, and we will have a list, that overall list. Oh, wait, no. We'll take this list, add the other list of things to it, and then send that. So for and then we will send this unloads. So if there's only a label, we will use the x, y, width, and height from the library. If there's a label, an x and a y, we will use the x, the width, and height as well as the script from the library. If there is a x, y, width, and height, then we'll only use the script from the library. And if there's an additional script, then we'll use a script from the library as well as the additional script. And then we will create that flavor. But just to avoid duplicates, because from here we're taking the script from the library, passing it, and it's going to be collected here. And we're also taking back the script from the library and adding it to this list here. Then if we have the x, y, width, and height, then we're not going to pass the script here. Like, happen. If we just have the x and y, we're not going to pass the script here. If we just have the label, we're not going to pass the script here. Because when we get to the end here and we get that FlevaClip, we will pass the script there. So just to kind of safeguard against those things, we're just going to send an empty list. And finally, create JevaClip must, well, it should possibly have a script. It should not be required. So in the create JevaClip, we'd have to put this. So one thing I dislike about Java, in JavaScript, I just have as many parameters as I want. And if this parameter is not undefined, do this or do that. However, in Java, if I want to create that flexibility, I just have to recreate an entire method for it, modifying some code. And it's really, I would say, time consuming. So if they do not have a script, it'll send an empty list. Otherwise, we create a JevaClip. Oh, I can probably just call it without. Yeah. With it. So at the top, we can create a JevaClip with well, we can create it, but we did not with the script functionality work yet. So for that, let's look at a JevaR object where there is a script hierarchy, which will be different from the unload script list. So I can probably properly name that unload scripts. And I don't particularly care for detecting each script in the clip, so I'll also use another list, and it will be scripts list. I will just execute it and all of that was added. So we need to, do we need to initialize a list? Yeah, we can. I think we can actually make this one an array list. Let's say scripts list is equal to new array list. Then we will have a method called add JevaScript, and it will either have a label or it will have just a raw script. And instead of the JavaScript library, we have a script list. We do not need to generate a unique ID, we just need to add it to the list. And we need to check if the main games library has that. So I'm wondering if I should make that a static property. So JavaScript library. So it'll be static. Does that break anything? It does not. Let's say JevaScript library. And we have to make it protected. There you go. So we try to get the scripts from the main library. And if we do, we will add it. I'll be using raw script. So that's how we can deal with that. And we're going to make this protected. We're going to make render protected. And we'll make that code protected because we only want, we'll also make these constructors protected because we only want the game engine to be able to create that. We don't want the developer to be able to create JevaClips directly. Because the game engine handles creating the JevaClips and storing it in the library and stuff. So we don't want the front end to be aware of that. They should only be able to add a JavaScript from the front end. Add JavaScript. And then in the tick, just like in the tick engine, we can run all attached scripts. And instead of the JavaScript library, it's going to be script list. Instead of a for each, it's just going to be for JavaScript scripts in the script list. And for each of them, this is what we want to do. Yep, that should do the trick. But final thing that we need to do before we start coding it is call that initialize method. So in our source where we say attach prefab, they need to call it somewhere. This is a mouse. This is in a scene. This is with FlevaClips. So add FlevaClip. It adds it to the hierarchy. And when the scene is loaded, it loads the FlevaClip. And that loading of the FlevaClip will call it initialize. So let's see where load is. Yeah, so attaching the FlevaClip kind of sets it to load, and then privately, if I have to load, will initialize it, and then unloading it will uninitialize it. So if we call load, so for load, yeah, so the load is where everything is initialized. So there's load and there's unload. Then there's tick and there's render. But is loaded private variable so that it doesn't multi-load. Okay, so let's implement that as well. So in our JevaClip, JevaClip will have a private is loaded. So a boolean like that, and upon initialization is loaded is equal to false. Then rather than an edit, it's going to be a load. So, and then we say if is loaded, return. Otherwise, do everything and is loaded equal true. So if is loaded, return. Otherwise, loop through all the initialization scripts and load everything, and then say is loaded equal true. If you don't have an unload just yet, go. So we won't do anything about that for now. But yeah, so when the JevaClip has been attached, and we put it in the JevaClip hierarchy, what we want to do is call JevaClip. Let's get reference to that JevaClip. JevaClip dot load, because we want to load it right away. And hopefully when we create the JevaClip, the scripts and all of that is just going to be stored. And when we attach it, it's going to be added to the hierarchy. It's going to be loaded. And loaded, now all the stored scripts are going to be executed only once, because it's going to only be loaded once. And then from there, inside of that unload call, anytime add JavaScript was called, these would go into the scripts list. And this scripts list of this JevaClip is what will be executed every frame, every tick. Because in our tick engine, we call that a lot every time. We call all the scripts. So let's let's run this and see. So let's kind of comment out all this code here. We'll leave that down there. So we're going to create one JevaClip, and we're going to add a script to it. The script can either be a raw script or it can be a string. Did I account for that when we do hash JevaClip with the script? I did not. When I did a create JevaClip. So it's just one script. So we also finally need one for creating one with a string script name. And then we say, we try to get that script from the library. So if that script exists, then we proceed. Otherwise, we cancel the function. So we try to get this script based on that script's name. And when we get the script, we will unload it. We will use it. So let's create a JevaScript first. So java.create JevaScript. It's gonna have a label move JevaClip, because this script's code will be moved on a JevaClip. So take self and is self everywhere is self. Yes. And now we say this is gonna be the unload. Is it gonna be telling me? Yeah. So load JevaClip. And here we would say when a JevaClip is loaded, we want to add a script. What script we want to add? The move JevaScript. Okay. So alright, let's define a move first. We can basically copy everything here. And everywhere that says JevaClip, we will just say self. Self cannot be resolved. We will say JevaClip. Clip is equal to JevaClip self. So self is like an object, and we're going to cast it to a clip. Now I wish it was easy to just directly do that here and cast it, but it doesn't seem like we can do it there, so we have to do it in line. So and then down here we just say all of these are the clip. So in a move JevaClip, we check if the key is down, left, we can move left, otherwise right, otherwise up, otherwise down on this particular clip, because this clip, so this will have a script. Whatever that clip that obtains a script, it'll have the function exception clip, and it'll move all these clips. So we'll be able to duplicate this. Now let's say Java.create. Let's add another JevaScript. It's going to be called load JevaClip, and it's going to have self again. It's going to cast that clip as well, and it's just going to say clip.add JavaScript move JevaClip. So when the JevaClip is created and loaded, it will just add one script to itself to be executed every single second. And now inside this create JevaClip here, we let's just pass a load JevaClip function from the library. So now that we have this JevaClip here, we no longer need to code reference to JevaClip because we can just attach a JevaClip, and it's JevaClip 1, and we let's just see if when we attach it, everything works. So I have some unsupported operation exceptions with abstract list.add inside attaching JevaScript. So let's see where this link errors out. So list cannot add because it needs to be an array list. FlevaClip, it is no longer going to be a list, but rather it's going to be an array list. And let's see where they complete. So it's going to be array list. And then it can't say arrays.add as list. So I'll have to initialize an empty array list.
All of tablets.
So array list equals new array list. And it just list. Constructor call must be the first statement in the constructor. That is tedious. Will be new array list. So just send an empty array list. But I wanted to have the unload. Initialize array list with one value Java. Arrays.as list and unload. There we go. So it was a bit of a pickle, but it seems to be solved. And now let's do the same everywhere here. So this is going to be an array list. It's not going to be casting anything. And this is also going to be an array list. So no complaints. And inside here, it's going to send a new array list, a new future array list. All of these are going to send some empty array lists. Okay, no more complaining. Let's try this. No errors, but does it move? Yes, it does. So we have successfully created a JevaClip with its own code. And to show that it works when we also duplicate that, or we're going to try to show because it might not work, but we coded it so that it should work. Let's attach another JevaClip, and this time we're going to set the X and Y positions to be, let's set the X to be something like 350 and the Y to be something like 150 or 200. And the first one will be at position 50 and also position 200. So we should have two JevaClips, and both of their unload methods should be loaded, which both of them should have the move JevaClip method. So whenever the left key is pressed, each of them would modify their own positions. So we have two JevaClips. If I press the left key, they both go left. If I press the right key, they both go right. If I press the up key, they come up. If I press the down key, they come down successfully. So that brings us to an end of this very long session, and we mostly did threads and scripts and keys. So threads, scripts, and keys. Now, I really don't like how it's moving so slowly because of the render problem, but Sue said he'd show us how to solve it by tomorrow. So when that's solved in the next video, I plan on adding images to this as well as sound. So the sound module will be pretty easy to add, but I'm not going to add that right now. But I think for images, I want inside of the JevaClips unload, I wanted to say something like clip that use graphic, and then it'll have the graphic name, and then that is how it will be drawn. And then as well, it'll also have, for example, JevaCreate graphic, and it'll have the name, and then it'll have the location of the graphic on that person's machine. So it will load that graphic internally. So all you need to do is create a graphic and point at where it is, and then in that JevaClip say, hey, use this graphic. And the JevaClip you will see that graphic properly being rendered according to the X and Y position of the JevaClip. So those are the two things we're going to do next time. As well as sound, we would have a Jeva sound dot create or Jeva.create sound. We give it a name and then a location for the sound. And finally, so path to sound .png, MP4 WAV, and then finally we would have Jeva sound.play, the name of the sound, and it will play. So those are the two things that we would add in the next time. So thank you guys for tuning in. We can see that we're actually having a game with lots of components. We can do a lot of more powerful things. Collision as well. JevaClips, we can have its own collide function that will detect if it's colliding with another JevaClip and be able to prevent different properties and things. But I think a lot of those interactions would be more enjoyable when we learn how to fix that rendering thing. Now, I also want to add some mouse properties, just like the keys, so mouse being pressed and released and the mouse moving around on the screen. So I think that will be in the mouse listener, but the mouse listener doesn't have the mouse location while it's being moved around, so I'll have to look into extra research for that. So for now though, this is what I have planned for next time, just the sound and the graphics, and I hope to see you again soon. Let's hope projects and everything don't keep me too busy to do this again, and hopefully it's not as long as this one either. But yeah guys, so I'll see you in the next one. I hope you have a good day. Bye.